Hello everyone, this is Pablo Barrachina, industrial engineer at MIWenergía, an SME electricity retailer which is one of the partners of the Greenfield project. I will start with the first part of the electricity market lectures, in which I will explain the energy actors that participate in this market. After this part, my colleague Anna from the company The Lab will talk more specifically about the Iberian market with close interest in the spikes of the electricity prices during the last few months. Here you can see the index. First I will do a short introduction, then I will show you the European legislation and the European agencies. Afterwards, I will talk about the traditional energy actors. Later, I will briefly explain the electricity market. And finally, I will give you an overall view of the new electricity system and actors. What I want you to understand from this lecture are the following points. How the electricity system works in the past and in the present and the future. Who is who in the electricity system, how the electricity market works, and who are the new actors that have come up due to the energy transition. So, how it went from this traditional linear flow, as you can see, to this more complex system that we currently have. Let's follow with the legislation and the agencies. During the last years, Europe has developed new legislation in order to overcome the challenges of the energy transition. The objectives are to be better connected and protected, more suited to integrate renewable energy, and more consumer-oriented. How do we achieve these objectives? First, allowing electricity to move freely throughout the EU. Also, enabling more flexibility. Fostering market-based investments and decarbonization. Introducing new emissions limit for power plants. And improving the response to electricity market crisis situation. In the next two slides, you can take a look at the European legislation. These two ones, the regulation on the internal market for electricity and the directive on common rules, are the ones that set the principles for the internal market of the electricity. Here you can see the European agencies where the TSO, DSO and regulators are associated. Now we will proceed with the energy actors. This is the traditional electricity system. We got the electricity generator, the transmission system operator, the distribution system operator, and finally the consumers. The regulator set the rules and the suppliers buy energy from the grid and sell it to the consumers. So let's talk about the actors. First, the electricity generators. They produce electricity like could be the thermal power plants, nuclear plants, hydropower, wind generators, or PV plants. Then we go to electric grid, which is the network that connects generators with the consumers. It's divided in two according to the voltage. The transmission network that transports electricity from the big generators, which are usually long-distance power lines with high voltage, up to 750 kilovolts, and are run by the TSO. Then the distribution network, that take the electricity from the transmission network to consumers. They are managed by the DSO. Smaller renewable energy sources, as solar and wind plants, fed directly into the distribution network and not in the transmission network. The TSOs are the ones that guarantee the safe technician operation of the power system and preserve the supply-demand balance. They are a natural monopoly. Frequently are state-owned, although is not always the case. They are independent from generation and distribution. The ENTSO-E is a European agency that gathers 42 members from 35 countries. The DSO is in charge of the distribution of energy to end customers. The DSO install, maintain, and operate the distribution network. It's impartial. It guarantees the non-discriminatory access to third parties. The EU DSO is an agency that gathers 898 DSOs from 34 countries. The DSO is legally separated from the free market suppliers, but is the supplier of last resort for consumers that cannot or don't want to be in the free market. Regulatory authorities assure that all stakeholders in the energy market comply with the national and European legislation. In the year 2000, the Council of European Energy Regulators was assembled to create a single, competitive, efficient, and sustainable EU internal energy market. ACER is a decentralized agency in charge of sustaining fair competition in the European market for electricity and natural gas. Then we have the supplier, which buys electricity from the producer through bilateral agreement or through the energy market, and sell energy to their customers. It's the balanced responsible party that balance expected demand and real consumption within its portfolio. And finally, the consumer demands electricity at high or low voltage, and in the past it was a passive actor. Now it can interact and become a prosumer, which I will define a bit later. In the next section, I will explain the electricity market. One of the objectives in Europe was the liberalization of the internal energy market for gas and electricity, which is not fully completed yet. We got the retail market. We have two actors, the suppliers and consumers, which are relation through electricity contracts. The price of the electricity bill includes the cost of energy production, but also the transmission and distribution network maintenance, taxes, and levies. The wholesale market. Here the actors are the generators, the electricity suppliers, and the large consumers. There are different types of relationships between them. The long-term contracts, up to 20 years and more, the forward and future market, from weeks to years in advance, the day-ahead market, between 12 and 36 hours prior operation time, the intraday market, with several auctions with different time frames, and the balancing market, which are real-time balancings of the supply and demand. Here you can see a graphic of the different markets according to the time before operation. The TSO runs the first and final market. Meanwhile, the day-ahead and intraday market are run by the nominated electricity market operator. Now I will explain a bit more the day-ahead market. It's a blind auction once a day, all year round for each hour. Market participants send the volume of energy they want to buy or sell and the maximum or minimum prices. An algorithm matches the demand curve, buy orders, with the supply curve, sell orders, and provide the final price for each hour. In this slide, we can see an example of the day-ahead market in Spain, run by OMIA, the national market operator. For each specific hour of each day, sellers and buyers introduce their offers. Usually, renewable energy producers introduce the energy at €0 because they cannot store the energy. Something similar happens to the nuclear plants because it's too expensive for them to stop. Then the rest of the generators set their own price and it goes up, as you can see in the green line for the sellers. Now we look at the blue line, the buyers, the purchase offers, where suppliers or large consumers do the opposite, place how much energy they need and the maximum cost at which they are willing to buy. On the left, on top left, it could be industries that need to operate all day or suppliers that want to assure that they have energy for the whole portfolio. Then other consumers could set a lower price. For instance, large industries that are only profitable if the energy costs don't cross a certain threshold. Then the order crosses until we got the first intersection. Later, the TSO checks the technical availability or the network restraint and adjusts the curve to obtain the final price. You can see the first intersection here, and there, after the TSO operates, the final price. The intraday market. It allows to correct expected deviations. There are two different approaches in Europe. The continuous auction model, that have auctions that take place on a continuous basis, and the hybrid model, with continuous matching combined with several auctions similar to the day-ahead market. Here you can see an example of the intraday market in Spain, that is a hybrid model. Now the balancing and ancillary markets, that guarantee and maintains the power quality and frequency at the lowest cost, usually due to deviation on the balancing responsible parties, scheduled production, or consumption. There are different types of balancing service: the frequency ancillary services, the voltage control, and the system restoration services or black star capacity. Now, finally, we'll talk about the new electricity system and actors. The energy transition aims to transform the market into one interconnected, more flexible, that fosters renewable energy sources, and more consumer-oriented. Due to this transition, new actors have come up. Let's see these new actors. Smart grids are energy networks that can automatically monitor energy flows and adjust changes in the energy supply and demand accordingly, with real-time information about consumption. Now, smart metering, electronic system capable of measuring electricity supply and demand, providing more information than the conventional meters, with hourly or quarterly consumption. Distributed energy resources, any electricity resource or controllable load at a small scale connected to the local distribution system. Here you can see three types: the distributed generation, which are power generating technologies in distribution grid, such as cogeneration units, PV plants, or wind generators; energy storage facilities, that are batteries, including electric vehicle charging station that could provide energy to the grid; and demand response, which I will now explain a bit further. The demand response is a change of electricity load by final customer from their normal or current consumption patterns in response to market signals. It uses the demand flexibility as an energy resource. There are two types: the implicit demand response, that are acting as a response to time variable electricity prices. If I provide information to the users about when the electricity prices are going to be the cheapest, they can then shift their loads to those hours. For instance, they can choose when to use the washing machine or the dishwasher. Now we got the explicit demand response, which are acting as a response to incentive payments. In this case, the DSO, the supplier of an aggregator, could offer incentive that could be money, a discount, or any kind of benefit to the end users to change their demands at one specific time. The aggregator is a new market actor who combines multiple loads of generated electricity, mostly the distributed energy resources, for sale, purchase, or auction in any electricity market. When this market participant is not affiliated to the customer supplier, is called independent aggregator. The aggregator gathers multiple loads. For instance, it could be the flexibility that can be achieved with demand response actions, and then put this flexibility in the market to get incentives and benefits for themselves and the end users. The prosumer It's an active energy consumer that not only consume but also produce electricity or provide flexibility. It could be residentials, energy communities, and commercial public buildings. To be a prosumer, you must use renewable energy sources or your flexibility with demand response actions. The energy communities are a partnership of citizens on collective energy actions. These are non-commercial entities which main purpose is to provide environmental, economic, or social community benefits rather than profit making. Microgrids, a group of interconnected loads and distributed energy resources within a clearly defined electrical boundaries that acts as a single controllable entity. It can work grid connected or in an island mode. Finally, we arrive to the new electricity system with the power plants and the transmission. Here we got the active network management that makes this grid, smart grid, the distribution with renewable energy sources, energy storage, district heating, and finally the end users with integration of the PV plants or electric vehicle chargers that also is connected in this way, not only in that way, as a prosumer to the grid. Thank you for your attention. If you have any doubt, you can contact me in this email.